I was about to say the same thing too. Hit record.
Yeah, I'm going to record it now. Sorry, I always forget. Okay, I'm recording this,
And
and
are you gonna share it?
I'm going to share it. Yeah, it just takes about like right about 1 hour for us to for me to get it on the YouTube. So sorry, sometimes that delay is like kind of makes me
Hello.
like who's
Let me.
something.
Can I ask you something?
Yeah.
I know we probably went over this a million times, but excuse me. Now the two middle C's, it has the double bond. But if the double, say hypothetically, if the double bond wasn't there, it
Mhm.
would be it would be 4 stars in the middle, right? Hypothetically, because
Yeah.
it would be like right.
Yeah, so let's do that. We should do what will help you understand. So so if there was no double bond here, then I would need to have these, because this has
Right.
two bonds still, so two more bonds here.
Right.
And
Okay. Now, okay, now when you put the double bond back,
Mhm.
uh, so you just have one hydrogen, right? So I mean, now what are you counting to make that two? You counting the one of the double bonds to make that two?
Great question. I told you, like I told you, I don't mind repeating myself at all. Okay, so what am I counting? Good question. So for any, yeah, this is something that I want to make sure that each one of you understands. So anyone who is missing, 1 2, so just look at, let's focus only on this carbon, the one that I have circled in purple. We are only going to focus on this one. Okay,
Right.
so in this one it has one bond on this side, which is shown, which I say is on the left side, which is showing in purple right now. I mean, and then it has two red bonds which it is sharing with the other carbon. So in all, it has 1 2 3. So what it is missing is another bond.
Okay, which makes it four.
Yeah. And
Oh, okay, okay, I
do
see.
you
And
see
then
it is this very similar one for
yeah,
this one?
okay, and then it's the same thing for the other side, pretty much.
That's exactly right. And that's a great
Okay,
question. Thank you for asking that question. I'm sure many people still want to ask that question and didn't ask. So please ask.
okay,
Okay.
thanks.
Anyone else having any questions about this example, how we did it? It's a 3-step process. I hope you saw that.
Oh,
Okay.
I missed it, Professor. Why didn't you
You cut off in between, Shai, or who's ever listening.
the
China. Yeah, China, what were you saying? Sorry. Go ahead. Why didn't I? Okay, you're getting a little cut off. Maybe you want to put it in the chat. Or try again, China. I might be able to hear you now. Okay. I guess there is some communication issue. So anyone had any other questions about this? So identify carbons, identify functional groups, put the structure, add the hydrogens. That's what we do.
I kind of have a question, but I also
Yes.
kind of get it. But I think maybe if you explain it again, then I'd get it. So I'm still having like some trouble with understanding like the functional group with it. Like I don't know how many carbons that it needs and everything, but sometimes with the functional group, I get like confused and thinking it's something else.
Okay, I get it. Yeah, we'll do one of those examples. Let's just move on for now, just in the best interest of time, and we will come back to that. And if not, then if I've not covered anything in the class that I promised, then you can just hang out for a little bit and I'll help you. Okay, so the second kind of questions are draw this or write this formula, and then example is given to you. So just like that, you have to write the formula and draw it out. So C5H8. Now it may sound very cryptic. C5H8, how am I going to even do this? Because I don't know what, what I'm being asked to do. Okay. So I'll try not to panic. So suppose I am you and I'm like trying this. I'm like, okay, how am I going to do this? So first, I know there is C5. So let me at least make C5. Okay. And now I can put only 8H. Okay. So I can at least, wait a minute, I hope this question is not wrong. Okay, so I can at least put the H over here and put the H over here. Okay. For the rest, I'm going to see if I can. So one over here.
I think you would exceed your hydrogens. You have to make 2 double bonds, right?
Yeah, yeah. So you can, we can do that. We can either do a double bond over here. Okay. So we're going to try now and see if it's going to work. So there are already three bonds in here. So it needs only one more. There are 3 over here. So this needs only one more. There are 3 here. So this needs only one more. There are 3 here. So this needs only one more. Okay. 3, 4, 5, 6. Now, what about this? This has 2. So we need actually 1 over here and 1 over here. Okay, now I'm going to fill this with the hydrogen. I told you in the beginning, this is easier to write. So just assume that the stars are hydrogen. Now, do you think all of them have 4 bonds? That is the first question that I have to ask you.
Yes.
Okay, great. So since everyone has, all of these have 4 bonds, and you know, hydrogen has a very minimum requirement. Hydrogen needs only 1 bond. So we already know that hydrogen 1 can form only 1 bond, which means that we have been able to make C5H8. Also, okay, also I can write this down by saying, I think what I did was I made a CH2 and then there was CH. I'm sorry, this is like, I get messed up. CH2 and then there is CH. Ideally, there is no gap. There is a like a subscript, sorry. Then CH2 and there is a CH and there is a CH2. I'm coming to the question in the chat. I'm just looking at this. So that's what it's going to look like. So again, what I'm doing here is, first of all, the number one thing I have to do is don't panic. If someone said C5H8, don't worry about H. Just put the 5 C's together, okay? So 1C, 2C, 3C, 4C, 5C. Now, you might have to do several iterations. Like I put 2 double bonds here. You might have to put a triple bond and try. But believe in yourself that you will find a solution, okay? So just put 2 double bonds here and then see if you can fix in and put the remaining bonds. And you can say, oh my gosh, no, you're experienced. I did not actually tell the solution. One of you told the solution, right? So it's not like I'm doing it based on experience. I was also going to do a trial and error, and you are doing the same thing. And if you are doing it this way, you can see that this particular molecule, if I was to name it, I can even name it. I know this is a pentene. And I would accept this answer from you, but if you wrote one carbon number 1, 2, 3, 4, 5. So 1 and 4 have double bonds. If you wrote 1, 4, that is also fine. I don't expect you to. So that's why I'm trying not to confuse you. But in a real world scenario, you will see pentene or you will see pentadiene, and you have to be like a little prepared for that. Just that the course, we are not doing a heavy organic chemistry course. So I'm setting a boundary not to teach you a whole lot, but I'm reminding you that in a real world, these names may appear a little bit differently. So main message here is, don't be scared of this at all. Put the hydrogen. If there any functional group you think, put it down and try it out. So please practice, submit, and you can always remind me. And like I said to you, sometimes, you know, I don't mind you reminding me one more time. So, I mean, we can always work around that. So is it okay if I clear this out? Because it's being recorded anyways.
Yeah.
Okay. See, I hope it's being recorded. Oh yeah, it's being recorded. Okay. So I'm going to clear this, and I'm going to go to the next question because we're we have hit more than 2:45. I want to go to these kind of questions because these kind of questions, especially the skeletal ones, can confuse you. So I want to remind you again, organic chemistry is all about, especially this part of biochemistry, which is the chemistry part, is all about being like, I got this, I can do it kind of thing. Not like, oh my gosh, I'm going to do this. This is complicated. No, no, no. Calm yourself down and say, I got this, I can do it. Okay. So first of all, when I see this kind of structure, what I do is I tell myself, remind myself how many carbons, same strategy, how many carbons? 4. Functional group. So the next thing is, what is the functional group? CONH2. So I go match the functional group, match the carbon, and that's it. I name it. And then you may say, what about this one? This looks like really like wacky. So, well, you have to always remember that whenever not given, these points are nothing but C's. Okay, that's a C, that's a C, that's a C, you know what I'm saying? And then you can say, what about H? Why is the H not given? This is a skeletal structure. This is a different way of representing, especially fatty acids, you represent like that. So don't be worried. This is just a way of representing. If I would be you, I would just count 1, 2, 3, 4, 5, 6. And are they H in here? Absolutely, there is H in here. I mean, you might have to figure out how many H's in there, but I know this is going to be H2 because this is 2 bonds, which means there are 2 more. So it's just a matter of sitting and writing it down and reminding yourself that the skeletal structure may not show C's, but they have C's in them. And of course, keep the functional groups close to yourself and see, okay, what is an OH? What is a CONH2?
I have a question real quick. When we see those skeletal models, do we always assume that it's a single bond and never a double or triple bond?
Yes, you should, because if it was a double bond, you will see this.
Okay.
And it will come up in the future chapters, modules, it's going to come up. So it's not like I'm trying to complicate. I do want to tell you that if you see these structures, it's going to come up in your fatty acid module.
Okay.
Okay, and then going to this one. So anyone who asked me assignment 1, question number 5, this is my response for you. So draw the hydrogen. So you have to find the hidden hydrogens by only doing one simple thing. Remind yourself every carbon can form only 4 bonds. And now you may tell me that question looks very different. And I'll tell you that that question looks different just because it has balls in it. Okay, so that's a ball and stick model, So essentially the balls or the ends, both all represent only carbon. Okay, so once you have a carbon, you know what to do with it because we talked about this. So if there's 2 bonds, then what you do is you form a 3rd bond and a 4th bond. 2 bond, 3rd bond, and a 4th bond. This is also 2, 3rd bond, and a 4th bond. And then you just write, here hydrogen. I'm going to just write for you just because, just for the sake, but you write these H everywhere, and then it will complete your structure. That's what I mean by adding hydrogens. How many hydrogens? So which means that you can complete the structure easily. Okay, so with this, do you have any questions about this one? I know we went a little bit quick, but do you have anything to say? Okay. All right, so I'm going to clear this. And
Sorry, are these gonna be like a exam question or something like that? Because like I just feel like I still don't get it as much, really.
Okay, try to see who's saying. Okay, was it Valerie? Okay. Okay, yeah, so we can hang out a little bit after the class, and I would like to know specifically what is the, how sometimes we get like stuck in something, like, like this little something. So I want to make sure that we clear that up and yet not hold everyone. So I will definitely get back to you. Okay, so now with this, I'm going to module 2. So so we did some examples of module 1, and good, you asked all those. Okay. Okay, so in module 2, we are going to study about carbohydrates, and we are going to learn about, their structures and properties. Also, we are going to learn about little bit about the functional assays and its relevance to your field. Okay, I'm going to skip this part because this is like all fun stuff to read. And I'm going to focus only on the stuff that we really, really need to focus on where you need my help. And feel free to stop me. Feel free to tell me to go back to the previous slide and all that. Okay. So these are the different ways you represent a structure. I really like this particular slide because it really helps understand that there is a Lewis structure and there is a structural formula, line diagram, condensed formula. It's also called skeletal formula. Condensed formula, ball and stick and stereochemical projections. Okay. So these are the different things that we learn and we are going to apply them for studying carbohydrates. Okay. So there are two types of carbohydrates. And now since you guys are familiar with aldehydes and ketones, so now it gets easier for me to explain to you that they can be aldehydes and ketones with alcohol groups. So now we are talking a little bit of the terminology we learned. Thankfully, the chapter 2, the module 2 is not so heavy in terminology. So we are going to be finding it a tad bit easier, I feel, than module 1. Okay. So what do we mean by aldose and ketose? So O's is for sugar. Okay. So whenever I say O's, it means sugar like glucose, simple. It's a sugar. And when I say aldose, I mean aldehyde. Okay. Aldehyde sugars. Oh, you don't see these slides in Canvas. Okay, I'm going to check it again because that shouldn't be the case. Yeah, I'm going to make sure that they are there, but I feel like something funny happened when I was transferring content. So sorry about that. I'll upload it right away. Okay. Now, the ketos are having the ketone functional group. Okay. And if you see here, yeah, I'm going to add that. Yeah, thank you for that feedback. So if you see here, there is a CHO and there is a CO. Now I want you to really, really focus and see the difference between an aldehyde and a ketone. We have shared it in module 1, but there's so much going in module 1. Maybe there wasn't enough time to appreciate that. CHO, these H additional, that's aldehyde, CHO in the end. It's always in the end because C needs 4 bonds. So double bond O, 1, and then the additional one is the H. However, when the same C double bond O is in the middle and it is having 2 different bonds with 2 bonds with 2 different C's, then you do not need that H. So the ketone is without an H, it's C double bond O, and CHO is the aldehyde. Okay. So that's what we are going to focus on. And this particular one that you are looking at, we can call it an aldotriose because triose, because tri is for 3 and there are 3 carbons here. Ketotriose because it is for, again, ketone, which is 3 carbon. Okay. So if you look here, we are basically introducing the term monosaccharides. Mono is 1. They are, saccharides. They are just one molecule. They're not like one joined with another. You will see when we talk about poly, then you realize that many of these can be combined together. They have 3 to 7 carbons and they can be either aldehyde or ketone kind of groups. Okay. The thing is that sometimes they get a little confusing because even though we call aldohexose, but none of you know what is aldohexose, almost no one, right? But you have heard about glucose like so many times, okay? So this means that, this means that this glucose is a 6 carbon aldehyde, okay? So we are going to just focus on learning now. And then once we're done, I'm going to upload these slides. Okay. Also the next one, aldohexose, is called D-mannose. Do you see the difference between the glucose and the mannose? I know it's very hard to see, but do you see the difference between them? You see this OH group, which was in glucose, it's like on one side, it's on the right hand side, and then on the left hand side. That's not what it is on the aldohexose, which is the mannose. Okay. So all I want to say here to you is that even though all are aldehydes and all the hexose, now with the term hexose is for 6 and for sugar. OSE is always the sugar. So similarly, galactose and fructose, all of these are sugars. Sucrose is a sugar. All of these are different kinds of sugars. And you can see there is one example of ketone, and the rest of the examples are shown by are shown to you are aldehydes. Okay. All right. So now, next, what we are going to do is we are going to look at how they can be represented. And for that, for that, I'm going to just talk about two different types of structure. One is the Fisher and the other is Howard projection. The Fisher projection is the one that is the long chain structure. That is what you are conventionally used to of seeing and much more familiar with. Okay. But the Howard structure is not very different. It's just made into a ring. That's what makes it different. But are they showing the same thing? Yes, the exact same molecule. Why do we need to study them in two different forms? Because if they're the same structure, well, in nature, they do exist in two different forms sometimes. So we want to make sure that we learn both the different forms that are existent in the nature. And glucose is going to be a really important molecule for you because, you know, in your field, you're going to be using glucose, the term glucose several times, right? So we want to make sure that we learn how it is represented. Now, this is the ring structure for glucose. Similarly, if you see here, this is the ring structure for galactose, and this is for fructose. So what this shown in the big on the left side is the glucose, and then there are some other examples that are discussed. I want you to pay very, very close attention to the fact that these corners, these are nothing but carbons. And now you may think, why are this not shown as carbons? This gets confusing. This gets confusing for you now. But remember that as you go on, you would know that every time you see a skeletal structure, the corner or the unlabeled is a carbon. So just for your clarity, I just want to show you that when you say one, what does that one mean? That means that that is the first carbon here, or carbon labeled as 1. This is carbon 2. This one is carbon 3. This is carbon 4. This is carbon 5. I mean, it's a little bit hard to see. So you can already see that it's not very easy to put all the carbons here because the neatness of the structure is lost. Now, just like you've been doing all this while in module 1, you have to also remember that this particular C has 3 different bonds. One is with the other C, one is with O, and one is with OH, which means that does it have an additional H? Absolutely. So as a person who is thinking chemistry, you always make sure that the C has its bonds that are filled. And similarly, you can do in others. So you don't have to in this case, okay? So this means that this is the first carbon, second carbon, third carbon, fourth carbon, fifth, and the sixth is a little bit like raised up in here. Okay, and similarly, it is shown here. I want to pause here and ask you if there are any questions about this slide.
Can you just explain what you were saying again, like with the glucose model? I know how you said that there's the C's on every single corner, but do you see where the one oxygen is? You confused me a little bit when you were talking about that part.
Oxygen, yeah. So to get to that, looks like you already know what is in our next slide. To get to that, answer that particular question, we'll have to go to the next slide, okay? And we will answer that question over there. So let's only look at the structure of glucose, okay? Because I don't know where this ring in the ring, where did the oxygen come from? Because we don't know, we haven't seen that before. So let's try to see how that came. So this is the glucose in Fisher projection. And what happens is that there is a possibility that this structure itself can make a ring. And this is the process of cyclization. That means it's forming a cyclic molecule or cyclic molecule. And in this one, though you don't have to remember or memorize any of this, this is just for your understanding that actually when that is happening, you can see here, if you see here, this is the exact same structure that you are seeing here. This is nothing, but this structure is a little bit bent. The CH2OH has come here. There is CHOH. So, and in the end is this first one, which was on the top. That's what you see here. And this is showing you the same thing. But when you see it over here, again, this is the exact same structure that you're looking. But when you see it over here, then this particular, there is a rearrangement. And due to this rearrangement, this oxygen forms a bond with carbon. If you see this pink, it forms a bond with carbon, okay? And this hydrogen kind of goes over there. So if you see here, the oxygen is now left alone as it has formed a bond with carbon. And this in below in here, there is a OH that has come here. And we are not doing nothing with CH. The H is still there, just that it's going to be shown on the top. So it has become an OH in here. And that means that it has been converted from a Fisher to a Howard projection. So so what we see here, that conversion, the only thing we have to remember here is we don't need to remember this process of cyclization. We have to remember that this O and C actually kind of bonded together. They kind of bonded together, and we still continue to have the same number of hydrogens and oxygen, just that they are arranged a little bit differently. And this particular carbon, which is attached to the oxygen, and it is the first one, which is actually responsible for this aldehyde group. This is called carbon 1. This is the first carbon. Then the second one is that, third, fourth, fifth, and then the last one is the sixth carbon. So we are looking at the same structure, but in a different eye because it is now a ring structure. Now you may say, why are there two of this? Why did you say this or that? Okay, so the reason is this HOH can arrange like that, or it can arrange in a reverse manner. You know, so this OH can go up and H can be down, or OH can, it can be in either configurations. Remember cis and trans, like that. So the alpha and beta are very common forms that exist. Again, nothing to confuse you. This is how it exists in nature. We are trying to just understand how these form. Now, this particular carbon has a special name, which you should know. And this name is anomeric carbon. Why is that? Because this is a carbon that is attached to two oxygens. So that is why it's got a special name. One oxygen here and one is there. And this is called anomeric carbon. Now, if you see here, there are two things that are circled here on the alpha side, and this is on the alpha, they're on the opposite side, and on the beta, they're on the same side. So I'm going to draw something, and I'm really, really hoping that's going to help you, because that's how I explain. So how I remember the beta form is I will be like, okay, when the structure is like this, I can form a beta here. Okay, so how I remember in the beta, they're always on the same side, because a beta looks like that. Okay, so they're on the same side in the beta, but on the alpha one, they are on the opposite side. Do you have to remember this? Yes, you really have to remember this. So that is why I'm emphasizing you on this, that there is alpha glucose and there is beta glucose. Both have an anomeric carbon. In alpha, they are on the opposite sides. The O's are on the opposite sides. In beta, the O's are on the same side. I'm going to pause here and let you ask any questions you have.
Can you explain it a little more?
Okay, I can explain to you one more time. Once you have come to the cyclic structure or the cyclic structure, different people will say it in different ways. That's why I'm trying to make sure I have both the pronunciations for you. So the first carbon is called the anomeric carbon, and the special name because this carbon is attached to two oxygens. Okay, so this carbon is attached to these two oxygens, and in here as well, it is attached to two oxygen, but you can see that these configurations are a little bit different. In one of them, oxygen is on the opposite side, so it's kind of far away from each other. And in one, it is on the same side. And you may say, does it really make a difference? And I'll be like, yes, it does make a difference. You know, these configurations have an impact in in biology, many of these configurations sometimes would even mean an enzyme can act or not act on this particular molecule. So yes, they are very important. So the alpha glucose is the one which has opposite oxygen on the opposite side, and the beta one is on the same side. And like I said, the way to remember is, like, I think of, so beta structure is like this. And I think like when I put the beta like this, I can always draw the beta. And so that's how I remember that a beta one is always on the same side for Howard projection. Okay. So with this, I'm going to then go to the next slide, and I'm going to share with you about the handedness. Okay. So what you see here is, and what you know, of course, is that your left hand and right hand, they kind of look the same, but they are not the same because they are not superimposable. So if you see in this really blue, nice picture on the left side, you can see that the left hand and the right hand, they are mirror images of each other. So if you put thumb to thumb and the small finger to small finger, you can see they're exactly identical match. But when you put them on top of each other, they don't really superimpose. This clearly means that they have different configuration. They're two different forms. Okay, they're mirror images, but they are not identical. Okay, now the right one is called in Latin is called dexter. So we have to remember that we are going to abbreviate that as the D form, the right one, and the left is called lavis. So we are kind of saved. We don't have to think of a different alphabet. So left is for L. I mean, L is for left and D is for right. Now, does it make an impact? Of course, it makes a difference. Like, I mean, these two chairs, even though they are the same, I know that, you know, the person who sits on this chair has to be right-handed. A left-handed person is going to be miserable. And similarly here, it does make a difference. And it is existent in nature too. And we can talk it about in a different way. We can talk it clockwise or anti-clockwise. So right hand, clockwise. And anti-clockwise, oops, like that. Okay. So this is the handedness, which we are going to look in terms of the molecules now. We just learned the concept of handed. Now we're going to see how that actually makes a difference. So things that are, okay. So if you, let's look at, don't look at the words, let's look at this side, okay? We are looking at the wine glass. The wine glass, they are mirror images of each other, and we put one on other, then they are going to be superimposable. This ball, well, that's superimposable. So anything that is superimposable, they are called non-chiral or achiral. Okay, that means that they are, you know, they can be superimposed, and whatever is shown in the mirror image, if you superimpose, they will be exactly the same. However, that's not really true for your hand, just like I showed you just now. Superimposable means one on top of another, and you can just try it right now. You can see the thumb sticking out, and there is no way you can fix it. Same thing with your feet. They really look like mirror images, perfect, very nice. But when you put them on top of each other, this is going to stick out on that side, and this is going to stick out on that side. So these are called chiral objects. They are non-superimposable mirror images. Okay, is there anything that you want to clarify in this, or was there anything confusing in this? Okay, so far so good. So let's talk about molecules now. The exact same thing is for molecules. Okay, so a carbon atom that is bound to 4 different groups. So this is a really, really important definition, not only for learning, but from exam standpoint and from assignment standpoint. A carbon atom bound to 4 different groups is said to be chiral. Remember, chiral is the one like your hand, chiral hand, that's how you remember, okay? So since it is chiral, it's going to have 2 forms, the L or the left form and D or the right form. And what is it called? It's called a special term that's called enantiomers. So just going to highlight that for you. This is an enantiomer, okay? So carbon that is bound to 4 different groups is called an asymmetric carbon. So I'm just highlighting the important stuff for you. Okay. And these are called the left and the right, or the L form and the D form enantiomers. Which means that, let's try to summarize this as shown in the green box. Chiral molecule exists as 2 stereoisomers. So we talked a little bit about the structural isomerism last time, but you were studying so much that we didn't really try to focus too much on that. So now is our time to focus on that. So they are called enantiomers. They are mirror images of each other, and they exist in L form and D form. So this is how we are summarizing this. Also to be noted in this particular, what should I say, the structure, is this R3 is coming out of the plane and the R4 is going in the plane. Now, I don't know whether you understand this part or not. So do you understand the meaning of R3 is out of the plane and R4 is going in the plane?
Yes.
Okay, and R1 and R2 are on the plane. So you have to imagine a 3-dimensional view of this thing. Carbon is on the plane. So, you know, I'm going to, I don't know if you can see me, but I'm going to try to see if I can explain this to you. I have pens in here. Okay. So this is, my hand is the carbon molecule. So if you see here, what I drew was carbon with R1 and R2. Now, if I have to draw R3, I'll be pointing it towards you. That's my R3. And if I have to draw R4, I'm going to point it towards me. So you see, in reality, the structure that you've been very comfortably drawing in like top, like right side, left side, bottom, in reality, the structure is nothing, nowhere close to that. So I know sometimes you feel it's tough, but for nature, it is even tougher. So which means that what you're seeing here again, carbon has R1 and R2 on the plane, and R3 and R4 are out of the plane. And you can see here that that's why when they're mirror images, they can never superimpose, because on the mirror image, it's going to come out like that. They're not going to be overlapping like this because they are not at 90 degrees, they are at different angles. Okay. Again, I want to pause here, ask you if you have any questions about this slide. Okay. Let's go to the next one then and try to see some examples this time. So one of our examples, the very first example is glyceraldehyde. You might have heard of this molecule, glyceraldehyde. If you have not heard, no big deal. We're not going to worry about that part. Does it have, so the first question you ask yourself, does it have 4 different groups? Well, let's see. We are going to draw this here. So one group is CHO, the other is CH2OH, third is H, and 4 is OH. Oh, they're all different. They're not nowhere same to each other. They're all different, 4 different groups. So can this be chiral? Oh yes, this can be chiral. We earlier came to an understanding that if a C, which is right here, this is the carbon right here, okay? If a carbon has 4 different groups, it's going to be chiral. Why? Because they are going to be mirror images, but they're not superimposable. Now you may say, why do you keep saying about these different, why, like do they really do something? Like in the nature, is the L form and D form really do something? Absolutely. One of them will rotate the light in the right direction and the other will rotate the light in the left direction. So they are actually very different molecules in the nature. And what we are doing, science is all an attempt to understanding what's in the nature and apply it for human benefit for most of the time, not always. So that's what it is, okay? So all I'm trying to say here is with this small molecule, I'm making my first attempt to explain to you what is L and what is a D isomer. Okay. All right, so let's see more examples. And this time, what will really confuse you is that there are multiple carbons. Don't worry about it. Just look at the one that is in the circle. We're going to look at always the bottom one. Okay, we're going to focus on that. So each of these, there are different chiral centers, and so let us look at this one. If you see here, OH is on this side and the OH is on that side. You see here how they are different. OH is on this side and that side. So this is D erythrose and L erythrose. And why are they isomers? I mean, why are they stereoisomers? Because they are mirror images of each other. But the moment you superimpose them, they will not superimpose. Similarly, L-threose and D-threose. Now, the first thing I know a lot of people will worry is, do we have to remember these names? No, not at all. Don't worry about remembering the names, guys. Just focus on remembering how we are doing this concept. That's the most important thing right now. Okay. So the more the chiral centers, like this has 2 carbons. So the more the chiral centers, the more the number of groups. And the explanation is given on this side. So D form rotates the plane polarized light to the right and L to the left. Okay, yeah, I don't know how much you are understanding, but I just want to make sure that I give you enough pauses to see if you have any questions. So if you have any questions, feel free to write it or let me know. Okay, so again, the question is why are, so what happens to, let's go back one more time. So what happens to these two? So they are exactly the same thing. Like, you know, if you count the number of carbons, all have 4 carbons, all have 1, 2, 3, 4, 5, 6, 7, 8. All of them have 8 hydrogens and all of them have 4 oxygens. So each one of this, if you're going to write the condensed formula, everything will look like C4, I'm coming to that question, 1, 2, 3, 4, 5, 6, 7, 8, H8, and O4. All of them have the exact same formula. It doesn't change. It's the exact same thing. And same on this side. It's the same thing. C4, H8, O4. And as a person who knows about this part of the carbon chemistry, you also know that carbon always forms 4 bonds, hydrogen always forms 8 bonds, and oxygen always forms 2 bonds. Okay. Let's see if any question. Okay, yeah, I'm going to come to that. Okay, so if you see here, these are all the same, but if you see these two, you see that OH is on both of the OH are on one side, and in this one, they're on opposite side. So these two have a special name. That's what we're going to learn in the next slide. And I'm going to come back for that question in the chat. Okay, so the thing is that this L erythrose and L threose, they are the same formula, but they are not the same. And these are called diastereomers. These are the stereoisomers which have different structures. They are not mirror images. And so they have this name. They're not enantiomers. I told you enantiomers are L and D forms. They are enantiomers, but these two is the orange group versus the yellow group. They are the diastereomers. Okay. Among themselves, left and right, or L and D, they are pairs and they are enantiomers. But among these 2 different groups, that's diastereomers. And just to remind you, going back here, this is achiral. If you see here the definition, anything that is superimposed on its mirror image, it's achiral. And anything that is not superimposable is chiral, and that's in your assignment also. Okay. So let us go to, now that we have learned 2 different concepts, we learned what is enantiomer. We have also learned what is diastereomers. Now let us go back to our comfort zone of different kinds of monosaccharides, because now we have learned that part. But as we go, I'm going to point you out to the yellow highlighted part of the alcohols, which will tell you that L and D form. Okay. So if you see here, this is glyceraldehyde, this is the L form and the D form, and there is OH on the left side. You're just looking at this. So right, left, just like, you know, you do the handedness. So that's the L form, and this is on the right side is the D form. And with the 4 carbon, which is what we did. Anything that is, just look at the bottom most. Don't worry about the other carbons. You're just looking at this one. If it is on the left side, those are L. If it's on the right side, it is D. Same thing. We're just doing the exact same thing, 5 carbons. So, sorry, this like hit it. This is L-ribose, L-arabinose, L-xylose, L-lysose. And this one, which is on the right side, D-ribose, D-arabinose, D-xylose, D-lysose. Are you guys getting a little more comfortable with this? Is this okay? Or is this still a little bit
Still a little confusing.
confusing? Okay. Yeah, and you should ask me questions because then I'll know where you are thinking and where I'm thinking and we can bridge that gap. But remember that you are looking at many OH. Don't look at that. Just look at this last one. Okay. The one that is close to. So you're just always looking at this last one.
That's the part I don't get. I know some, I think probably everybody had the same question that I do. It says 5 carbons, right? But usually for carbon, I will see the C. I only see one. So that's my confusion.
Yeah, so I mean, it can be confusing in the sense like you may think for L-arabinose, for example, like why are we not looking at this one and why are we looking at this one, right? Yeah, so this round we are going to only learn and then we're going to go into a little more detail, but just for your convenience and just for you to remember this part, I want to say that whatever is the carbon before CH2OH in the end, that is the one that you're looking for doing the handedness. So that's what we'll do now. And we're going to do the same thing. We're going to, whether you're doing 4 carbon, 3 carbon, 6 carbon, if you see here, the exact same thing in here. There are so many different 6 carbon sugars. There is 8 different ways you can write that. And then you can see all of these are aldehydes. They are all CHOs. There is, depending on the structure and depending on the OH arrangement, they're going to change. And I mean, the last carbon, that's, or the chiral center, you know, I mean, I know we are still getting familiar with terms, but remember you have 2 weeks to go through it and go through the structure and everything. And then let's see. So this is the entire, this is the summary of all the, yeah, this is the summary of all the terms of all the different monosaccharides that we have learned so far. We learned about glyceraldehyde. We learned about the 3 carbon ones. We learned about, sorry, that's 3 carbon, 4 carbon, 5 carbon, 6 carbon. So just like, this is kind of nice for me to like always think of all of the aldehyde sugars and the next one for all the ketone sugars. And, you know, for me personally, like, just like you, I'm more familiarized with glucose or mannose or galactose. And in the ketone one of them would be fructose. So those are the, yeah. So those are the things that we are just going to be thinking about. We are not at all going to focus on the xylulose or erythrulose. No. We are not going to worry about the nomenclature, unlike the module 1. We are just going to focus on learning the concept of chirality, enantiomerism, L-formed and D-formed. Okay, so let me go back here. Okay. So how do we name these? How do we name these structures? Okay, so I'm just going to give you a brief of this, and I did not initially have this slide, but I did realize that when you are looking at these some of these things in allied health field, I mean, you're going to look at some of the structures like that, and it's going to be looking a little unfamiliar. So only what you need to know. That's what I'm going to be sharing here. So when you talk about the carbon, it can be alpha or beta. I'm going to slow down here because we talked about anomeric carbon. If you remember, the anomeric carbon is the one attached to 2 different oxygens. Okay, so there can be alpha form, which is the opposite side, beta on the same side. Configuration of the sugar is a D or L. What is the prefix of the sugar? Glucose or fructose? What is the ring type? Pyron or furon, and here, if you see here, furon is the 5-membered and pyron is the 6-membered. And since it is a sugar, we ended with OSE. So this is how we name the ring structures of the sugar, by calling them alpha D-glucopyranose or beta D-fructofuranose. The goal is to make sure that you understand that each of this element is something that you have learned. You cannot have any control on gluco or fructo, but you should know what is alpha and beta, and you should know what is L and D forms. Not like you should know right away, but I'm just saying we talked about it and you are going to review it and eventually you will know about it. That's what I mean to say. Okay. So here are some examples in here. I encourage you to do the learning check, because the learning check is in between given, because what happens is you come here and you say, I think I understood everything. And then you look at the learning check and you're like, okay, I don't remember what is this or what is that. So please do that. Okay, so is there a significance of L form and D form? All the sugars in nature are D form, everything. That's really, really interesting. So our body only deals with the D form of sugar. We don't deal with the L form. And when you go to another chapter, you will see it only exists in L form. All the amino acids are only in L form. Okay, so this till here, this finishes that confirmation, configuration, or learning of the chemistry part. Now we're going to move on to a little bit more like reactions and what is their uses. The time is right now 3:30. I do want to remind you that, I mean, I'm going to be here making sure I explain the whole thing to you, but I do respect your time. So, I mean, lecture is already should be uploaded according to me. If I do hear there is some discrepancy between what I uploaded and what you are seeing. So I'm going to make sure that it is there from before, that is from last semester. And I'm going to continue and try to finish it in like 15, 20 minutes, but you are welcome to do what suits you the best. Yeah, the quiz that we have reopened, you have till Friday. I don't believe in like rushing you ever.
Wait, so sorry, I missed that part. So did you reopen the quiz? Are we allowed to retake?
Yeah, the quiz one I reopened for you guys. I just want to make sure that I share it with you. I have sent announcements. I have also put in GroupMe. If you're not joined GroupMe, please join GroupMe. It's really helpful. Till Friday, you have time to do it. It's not like every quiz is going to be reopened.
Okay, thank you.
Only if I feel appropriate that there was really a problem, which is to me only, it happens only when everyone has done the quiz, I can go back and analyze and if there was actually an issue. So yeah, I mean, the average was a little low, so I opened for everyone. Feel free to do it. If you have 9 and you get a 10, great for you, you know. Okay, so reducing sugars. So all monosaccharides are reducing sugar. What do we mean by that? Okay. They mean by that that these sugars have a free aldehyde or a ketone group. Okay, and we're going to cover a little more next time, because this reducing sugar concept does like kind of get you later, like initially you understand and then you're like come back and okay, didn't quite get it. So there is a way we can test the reducing sugar. So how we can test the reducing sugar is by Benedict's solution. And I'm sure some of you who have done Bio 102 with, you know, I don't know, some people think with Dr. Mala, Dr. Samson, all of those people, and some other people, you might have seen or done those reactions. Okay. So what happens in the reducing sugar is that the copper ion is, sugar gets reduced and the copper gets oxidized. And when it gets oxidized, it becomes red in color. So if you want to know whether a sugar is reducing or not, and you added that agent Benedict solution, which is actually just having that copper, if it converts to red, then you know, okay, this sugar was reducing. And that's why the copper became red or oxidized. And if the sugar was not reducing sugar, then the copper will do nothing. So it'll remain whatever color it is, not a reducing sugar. Okay. So that is this test. And so we are coming to the lab side now, you know, how we are just migrating from this one topic to another. So they're not only just one reaction, but they're different types of reactions that these sugars can do. They can, you know, there can be phosphorylation of sugars, like they can get modified. Okay, they can get oxidized, they can reduce, they can be other modifications that can happen. Why is this important for you? You may, like, it may come up in something, you know, I don't know, patient report or something. It's hard for me to say, not really on the nursing side or the medical side. But I'm just saying these are some of the things that could be important biologically. Okay, so what happens is that there is these are the so far what we have been doing is the monosaccharides. Okay, but what happens in nature is there is not just monosaccharide, but there can be disaccharides or there can be polysaccharides. So how do the disaccharide form? They form by what we call a glycosidic bond. A glycosidic bond is just a fancy name which connects two monosaccharides. It's nothing, it's just making it from mono to di. Okay, so if you see here, this is, okay, I'm trying to see here. These are the different examples of maltose and cellobiose, which kind of show you, you know, the different glycosidic bond. If you see here, this is the alpha. The reason this is alpha is because it is the O is in the opposite side, and this one is beta, where O is on the same side. Okay, and here di means two and poly means many. So what are the other examples of disaccharides? So it could be sucrose with it could be a sucrose molecule, which is a glucose and a fructose combined together. And you can see this is a pyrene ring, which is a 6-membered ring. And this is a furan ring, which is a 5-membered ring. Similarly, a lactose is galactose and glucose, and a maltose is a combination of 2 glucose molecules. Now, here is where I would say, please remember this, because this is something, these are the typical questions that can come in a quiz. And you know, you're expected to spend 30 seconds on it, but because you don't remember, if you go back and look in the slides, you're going to lose time. Things to remember, definitely these 3, you should remember that maltose is a combination of glucose, lactose is glucose plus galactose, and sucrose is glucose plus fructose. And you can find some fun ways to do it. You know, I mean, you know, whenever I think of lactose, I think like cancel the glue and then you'll get the lactose. That's how I remembered when I was a student. I remember like, okay, glucose, galactose, and I'm just going to remove the G's and just remember the lactose. So you can discover some fun ways of doing it. Polysaccharides. Polysaccharides are the one that can go on a little bit longer, like cellulose, starch, glycogen, and iron. Okay, I want you to take a really, really good look at the structure and tell me if all of these cellulose, starch, and glycogen are made up of glucose, why are they having different names? Are they any different? Do they look any different?
Yeah.
At least cellulose and starch looks different, right?
Mm-hmm.
Okay, and I'll tell you how they're different a little more using this chart. And again, this is something important. So if you see here, glucose, starch, and glycogen. First thing, cellulose and starch are in plants, and glycogen is in animals. Okay, cellulose is made from a repeating unit of beta glucose. You have to remember that anomeric carbon can have alpha or beta configuration. Starch is all alpha glucose, and glycogen is also alpha glucose. That's how their glucose is stored. When there is a lot of glucose, it can be stored as a chain structure. However, the way the first carbon structure bonds to the next one, which is shown by, this is number 1 and this is number 4. 1, 2, 3, 4. I'm sorry. So this is 1, 4, 1, 4 linkage. Okay. So this is a 1,4 linkage, but in amylopectin, which is a different kind of starch than amylose, there can be 1,4 and 1,6 linkages. You see here, It's 1, 4, and this is 1 with the 6. Okay, so there can be different forms of within the glucose chains. So in cellulose, there is no branch. In amylose, there is no branch. In amylopectin, yes, there is a branch. And also in glycogen, yes, there is a branch. As a result of which, even though at a molecular level, we think everything looks same, they actually don't quite look the same. Because of these minute differences in structure, you can see here, this CH2OH here, CH2OH here is the same side. The cellulose is more like straight, and that's why it's kind of hard to, it's kind of hard to enzymatically break it out. The amylose is like more like this, like a chain like thing. And then amylopectin is a branched starch, but if you see glycogen, it's highly branched, small, many branches. And that's what distinguishes starch from glycogen. So yes, starch and glycogen, even though they looked kind of same here, they're not the same. They're structurally very different things, and they're present in different things. So again, this is another typical example in quiz, like if asked, or in exam, if asked like, where is glycogen present, where is starch present, you're expected to kind of know the answer. Okay, and that will help you save some time. So there are different kinds of these complex carbohydrates, just revisiting them. Starch looks like this, potatoes. Glycogen looks like complexed or very branched, that's liver. Cellulose looks like that, as in algae or in plants, and chitin looks like that, as in the tick, the cutaneous covers of insects. And so this kind of summarizes the monosaccharide, disaccharide, oligosaccharide. Oligo is 2 to 10, and poly is many. So these are just a summary of that. And then there's some medical uses which you can read by yourself. So like I promised to you, I kind of did want to finish before 3:45. But I want to know if you have any questions from any topic or any given point in module 2. Anything that you want to ask, you can ask or put in the chat.
I have a question about assignment 1.
Yes. Yes. Oh, you have a question about assignment 1. Okay. All right.
So I just need like clarification on like number 8.
Okay.
Like what it's asking, because the functional groups like isn't that ether ketone, like aren't they listed already?
Okay, I'm going to address that in like 5 minutes.
Okay.
So let me first ask anyone who is there, like, is there anything else that you want me to address right now about module 2 PowerPoint or anything related to that, except that I know I need to make sure that PowerPoint is uploaded.
So you're gonna upload the PowerPoint?
Right away, the moment we are done from the
Okay,
class, I
thank
will.
you.
I did not realize it was not uploaded because I transferred everything from the last time and I assumed it was uploaded. And are you comfortable with all the communication in Canvas and GroupMe, and do you feel like it covers everything, or do you feel like there are gaps in information or you don't know something? Okay. Yeah, I mean, let me know. I mean, if you're missing something, let me know. And regardless of how you are doing, if you have any questions, you can contact me. You should not feel like if I'm not doing well, that means I'm not studying or something. I mean, we need to sort this out, like in the beginning itself. If you have any issues, we'll sort it out together. Okay. You don't need to feel like I need to do this all by myself. But I do have a limitation on time because, like I told you, my full-time position at NIH, like I have to work 9 to 5. So it's not like I'm always available, but I do try to the best of my ability, try to answer questions in text as much as I can. I don't mind reminders. So that's fine with me. And I know some of you, like, I think sometimes if I don't respond, maybe the answer is like, if you said something, I'm okay with that. Like if you said something like, okay, can I do this at this time? Or, it's like okay with that. So now I'm going to start with assignment 1, clarifications on assignment 1, because there were a couple of people and assignment deadline is tonight. So if you wish to stay for assignment 1, you are welcome to stay. If you feel like you have any other questions, you can ask now because we're going to start in 2 more minutes. So, okay. No more questions. So I'm going to go back to assignment 1. I just want to clarify to you also that I cannot tell you the answers for assignment 1, but I can provide you support at the same time and clarify anything that you need to know. Okay. So let me just open that assignment. Also, I have noticed one thing. Out of typically the 25, 30 students I have, one student have problem in opening the assignment. I do want to let you know, as much as I want to help, there is also some problem in, I don't know, like some of your Word or Microsoft or whatever versions that kind of, what should I say, that kind of prevent you from opening the file correctly. Okay, so that's not intentional on my end. And I for that reason, I uploaded PDF also this time, like you can try that. Okay. So my first question that I had was about, someone had a question about assignment, question number 8. Okay.
I have the same question as well. I wasn't sure what were you asking in there because I still scratching my head about it.
Yeah, I feel like the functional groups are listed. I thought that's what ketone, ether, and the other ones were.
Yes. So you can, yeah, so you don't have to decipher the entire molecule for me or anything like that. It didn't mean that I wanted you to name it or find every single functional group. I wanted you to identify as many as functional groups you can. So I cannot show you the answer for this, but I can maybe discuss something. Give me a moment and I'm going to discuss something which is like in another drug. Let us see if I can pull up.
Question. Is that a triple bond right there?
I don't think there is triple bond. I navigated to another page to find something for you, but give me,
Oh, it's double bond. Okay, never mind. Yeah.
I'm going to find some another. I just picked up a random antibiotic. You know, it's not like, not even. Oh, of course, it has to be something funny. Okay, yeah, like that. Like, okay, like that. Like, this is some antibiotic, and let me tell you the name for this. The name is Quinolone.
And it have alcohol right there, right?
Yeah, so yeah, like that. Yes, that's exactly what I want you to do. So I just want you to, when you see a medication, you're going to be working in the field, you're just going to see medication. I just want you to be able to see the chemistry side of it and be like, oh, okay, well, it has this and it has a fluoride and it has an NH2 group. It's another N. You know what I'm saying? I am just telling you, based on the knowledge of the functional group you have, can you identify a functional group in there? That's all I meant for you to do.
Okay.
So if you see a structure like that, like let me draw another structure, and it could be, and I know this is like a skeletal structure ending with OH. Then you didn't have to do the whole structure for me. All you needed to do was say to me, oh, I see only one functional group, and that is this. I don't see any other functional group. Rest of it is, it's a carbon chain. This is carbon. I know this is carbon. This is carbon. I know the rest of it is all carbon. So according to your ability, I wanted you to go a little bit outside the box, not to trick you, just go outside the box, think. These are the functional group. Do I see any of these over here? That's all I meant for you to do. Okay?
So we just write the name.
Yeah, just circle that and write the name. And just say this is the group and according, or this is the name. That's it. Any other questions about question number 8, or any other questions that you have about any other question in assignment? In assignment 1, yeah. I do want to tell you one more thing. Whenever I ask you to draw a cis and transform, or I ask you to draw something, maybe not every place says the name, but I can tell you about half the students do write the name. I just want to mention that, and I really appreciate that part. I know I asked because I'm trying not to freak you out, so I given you only like, let's say draw this or draw that, but I would really hope that you are writing names, especially for this particular question. It's not like I'm taking all the points off, but out of 4, I did take 1 point off, and I did say resubmit if you did not write the name. So give an example. There can be so many examples of 5 carbons. So give an example and then share what did you draw? Like, do you know what you draw, or like you are just kind of guessing it? So I do want you to do that, and I will add here, name them, but for now, I mean, too many of you have downloaded it already, so it doesn't make sense to put an updated assignment. So I'm just telling you verbally.
Can you give another example about like the belts, but with the triple bond? I feel like I get the first and the second bond, but not the triple bond, and I feel like that's important.
You mean like this third one? Like
Yeah, like that one for triple bond. I mean, for example, on this one, okay, I get it. You cannot tell me the answer, but this one already have the 2 hydrogens in there. So for a triple bond, will this still will have only 2 in the end? That's the part that confused me.
Okay, I'm going to stop share. Okay, I'm going to show you with another example.
Yes, please.
Yeah, I definitely feel like you guys could use a little more help in here. Okay, so which one should we do? Okay, let's do this one. I'm going to modify this. Or maybe create a different example. Okay, I can just create one example, which looks kind of similar, but okay, so I'm going to have here, let me try to grab a structure from internet. Okay, not too many useful things. Okay, I'll just draw it. It's okay. So let me just say in terms of C, I hope that, I mean, I'll make the balls as well. Okay. So let us say that I'm just drawing a random. It's kind of hard to see. Let me make it larger. Triple bond I cannot make, but I can make this because I can come back and draw additional ones. Okay, so I have drawn now, and now I'm going to make triple bonds by making one bond over here and one bond over there. Okay, so now I need to make sure that I have enough carbons, I mean, I have enough bonds. So there is only one bond. So let me make the bonds with red. Filling up is, you know, there are going to be 3 in here. This does not change if I put the carbon like this or if I put the carbons like that. It's going to look the same. Just saying, okay? Just for the clarification, since we are discussing that question, I want to make sure that I'm covering it as such. Doesn't make a difference what you do. Okay, so there are 2 here, so 3 and 4. There is 4 here, 1, 2, 3, 4. Nothing that needs to be added then. For this carbon, 1, 2, 3, 4. Nothing needs to be added here. These are 2. So 3 and 4. These are 2. So 3 and 4. Do you agree with what I did?
Yes.
Okay. So you know this chemistry part, like where you are. I mean, this.
So we never. I'm sorry for interrupting. So we never gonna put like an extra bond where the triple is. We always put on the singles, right?
Yeah, but the triple one I mean, there is one here. Are you forgetting that we are catering to the
Okay.
carbon?
So we always have one for triple. Okay, that's my question. Okay. So
No,
it's
no, no.
always-
Triple. These are 3 bonds. Let me show you. This is 1 bond, 2 bond, 3
Three
bond,
bonds.
4 bond. So this carbon has 4 bonds are completed.
Okay.
Similarly for this 1, 2, 3, 4. You can only have 4 bonds. You can never have more than 4 bonds. You know what I'm saying? So that is why we don't need to add bonds over there.
So it's always 4 pretty much.
Always 4, no matter what. It's always 4.
So as we have a double, that's why on the double we put 2. That's what my confusion was, because I remember we have an example of a double and there was 2 in there. And then at the end we put 2 because it was a double bond. So you need 4 in order to be complete. Am I right?
If you have double, well, let us say that, let's modify this one and just hypothetically, let's make 2 bonds in here. Okay. If that happens, then I'm going to have to, so there are 2 bonds here, 3. So I'm going to have to erase this one. Oops. I knew it was going to do something crazy. So yeah, I have to remove, I will draw the rest later. So I have to remove this one. So now 1, 2, 3, 4. And in this one also, I have to remove this one. So you see, I am doing something really, really simple. I am just making sure that the carbon has 4 bonds. So do you see that how I changed the number of bonds just because I want the carbon to have 4 bonds? Does everyone notice that how all the carbons still have 4 bonds?
Yeah. Do we have to write the structural, what is the structural formula for that too?
Do you have to, I mean, you know, not for me, but for yourself, I would say it would be a really good idea to write. And it doesn't take too much time, but it will really help you.
So you never put hydrogen on the double bond or triple bond.
You only put if needed. So here you did put, you see, you did put.
What about the middle where the triple bond is? You never put it.
Because it was in the middle. So it has 3 plus 1, 4.
Okay. Okay.
I mean, that's what it is. I mean, if it was in the end, then it probably need 1. That's what happens, right? If it is a ethyne, that it needs 1 each.
Okay. So since it has 3 triple bonds, that equals 3.
Yeah.
Okay.
Yeah. So, I mean, if you see here, if you see this one, and it has, let us say it has 3 bonds because it has this one. We're just talking about an ethyne. And just consider all the colors to be same. This is a triple bond. Well, it does need a hydrogen over here. Okay. And it does need a hydrogen over here. So as long as you're fulfilling the 4 bonds, we are fine. That's what is the main message to understand here. And writing the structural formula will only help you enhance your understanding. That is why I give some practice sheet with extra formulas like for you to write.
Okay.
Anyone else has any questions about specific things in this practice sheet or concept wise or any of those?
If we submit the practice sheet, will this be graded or uses extra credit or anything?
Yes, no grade. No, there is not extra credit. So it's up to you if you want to do it. Maybe you want to do it before the exam or something. I just
that's
put
practice for us, extra practice.
Yeah, just for you.
Okay.
Yeah. Anything that is graded, I'll put it there. But this one just people wanted extra practice. And also I forgot to mention, but I'll be putting out the exam one schedule pretty soon, so that some of you want to be done earlier. Like, let's say you already finished assignment 2 and you want to be done with the oral part, then you can be done with that. So I'm going to put those announcements out soon. Anything else that you want to share with me?
No, I think I'm okay.
Okay.
Yeah, I think I'm okay as well. We just went through everything.
Okay, that sounds great to me.
Professor, I will be making my trip back to the United States next week because right now in Peru and they're closing the borders in here.
Oh yeah, I know. Yeah, I'm cool with that. Whatever you wrote in the email, I'm fine, and you can just
Yeah.
accordingly,
Because
whatever
we
works for
can
you.
met like because I'm living on a Saturday, it takes almost like a day to get back. So I
Same
will.
here. When I come from India, that's how long it takes. So,
Yeah, it's like a 15 hours trip because I'm in South America. So I will not be back until Sunday, like around 2, and then I had to obviously get home. So I probably will not be in class next week. So
okay,
we'll try
that's
to be
fine.
able to meet, like, to cover up on what I missed on class that day because I really don't want to miss class.
Yeah. I mean, we are going to cover just we're just going to go into details of module 2 if needed. But the week where we don't discuss modules are the chill weeks, where it's more like your problems, like you bring your things and ask me questions. Okay. So, I mean, we'll just practice more. We'll go over details of questions, what kind of questions, and if there is anything that I can do for you. That's what we do.
Thank you so much.
All right. Anyone else with anything, you can always, reach out to me later or whenever you feel works for you.
Professor, I missed the first two meetings. Were those recorded?
Yeah, they're recorded and posted.
Oh, where can I find them?
It should be on the canvas because let me show it to you. Okay. Let me show real quick because I know some people joined later. And that's always a problem. Okay. Give me one moment. Let me make sure that I'm on the right. Okay. Now I think I'm on the right page. Okay. Okay, so this is our thing, and I'm going to modules. Everything is always in the modules. And according to me, I opened everything. I don't know if you see it. Office hours, January 17th, office hours, January 24th. And even if you do not have the office hours, for something, you have the entire lecture recording from the last time, which is pretty much identical over here.
Okay, thank you.
Yes, it's all in here, and all the things that you need for module 1 are here. And similarly for module 2. The only thing is, for some reason, oh yeah, that thing is missing. Okay, I'm going to upload the PowerPoint for you. Please stop sharing. Okay, anyone else has any other questions, guys? I hope you're finding it. I hope you are finding it. It's okay. You're getting adjusted well to the course expectations. You were able to read, and I can see that many of you are spending a lot of time and doing everything. So keep doing what works for you, whatever is the best for you. Okay, if there is nothing else, I can hang out for 5 more minutes for anyone who has any individual questions, but I hope you enjoy the rest of your evening, and I will see you next Sunday again.
So as far as like uploading the assignment is concerned, now did you say in the description you can take a picture of it and upload it? Did you say that?
I did say that.
Okay, so like
Because most of the people want to do that only. But I really appreciate when you load PDFs, because some people did load PDF and that was so much easier.
okay, I don't know how to like. Okay, I mean, I don't know how to like write on it, like like do the, not type on it, but like write like a image on it. You know what I mean? Like,
So some people were
Mhm.
they were taking printouts. Most of the people,
Mhm.
I feel, they are taking printouts and they are finishing it up and they are just uploading pictures, which is fine.
Oh, okay.
And other people who maybe
I
have,
don't have a printer.
and for those who cannot, they are just writing it on the Word, and people like that a little bit better, though it makes the work harder for me. But the reason I have this assignment is because you can open and do them at your convenience, and you didn't have to be on Canvas logged in, and you could just slowly do them over a period of time, and look back things and do them instead of having the Canvas open and
Right.
having you logged out or whatever. So
Okay.
yeah, you can do it in Word. And many people asked me in the beginning, like they did not have Word, and they said, can we just take printouts and upload pictures of the entire assignment? I said, sure, you can do it.
Okay.
Yeah, but people will also sometimes they will write on a plain paper. Sometimes for some things, and they would upload a picture of the question.
Okay. Yeah, because that's what I had started doing actually.
So some people were doing that, and that's what's going to happen in the exam one. Like when I ask you to do something or draw something, you're going to just be drawing on a plain paper and just like share a picture with me immediately. And
Okay.
that's cool with me. Like if you don't have a printer, like how are you going to get a printer for this class? That's not needed. So
Yeah.
you can do that. Whatever works for you. I just like the PDFs a little bit better. I know some of you did upload PDF. That was nice.
Right. Okay. All right then. Thank you. Appreciate it.
Take care.
Have a good one.
Bye then, Paris. All right, guys, I will see you then. And I'm going to end the recording now.